Have you ever pondered what exactly determines the properties of materials? It's a fascinating question, isn't it? To answer this, we need to delve into a world that exists beneath the surface, a world that forms the very essence of materials, their composition, phases, defect structure, and residual stress. Imagine a material as a complex, intricate puzzle. Each piece of the puzzle contributes to the overall picture, or in this case, the properties of the material. One of these pieces is the composition of the material. Sure, it plays a vital role, but it's not the whole story. For example, a few tens of parts per million of oxygen in copper can degrade its conductivity. That's why oxygen-free high-conductivity copper exists. So while composition is critical, it's not the sole determinant of a material's properties. Next, consider the phases present in the material and their distribution. It's not just about the amount of phases present. A small amount of cementite along grain boundaries can significantly reduce a material's impact toughness. It's the distribution of these phases that plays a crucial role, yet it's not the only factor. Now delve deeper into the puzzle, and you'll find the defect structure. Defects aren't always bad. In fact, they can give materials unique properties. But dislocations, a type of defect, can severely weaken a crystal. So, the defect structure in the phases present and between the phases is another critical factor determining a material's properties. Finally, there's the residual stress. This is stress that's locked into a material, even when it's not under any external forces. Interestingly, the presence of surface compressive stress can toughen glass. Residual stress can have multiple origins and may require traveling across length scales to fully understand. So what determines the properties of materials? It's a combination of composition, phases, and their distribution, defect structure, and residual stress. But remember, these factors don't act independently of one another. They intertwine in complex ways, each influencing the other. In conclusion, the properties of materials are determined by a myriad of factors, each playing its part in the grand scheme of things. It's not just about what the material is made of, but also how it's structured and what residual stresses it holds. These factors, in their intricate interplay, give rise to the diverse range of properties we observe in different materials. So the next time you look at a material, remember, there's a whole world of complexity beneath the surface.